What invisible threads weave the tapestry of existence? What unseen power glues your very being to the earth, or ignites the fiery heart of our sun, bathing worlds in light and energy? These are not idle questions. They are gateways to understanding the fundamental architecture of everything. The cosmos, in all its bewildering complexity and breathtaking beauty, operates on a set of rules, governed by forces that, while invisible to our eyes, dictate every interaction, every structure, every moment, from the birth of stars to the silent hum of your own thoughts. It all comes down to a quartet of cosmic influences, four fundamental interactions that sculpt reality itself. These forces are the unseen hands that shape galaxies, bind atoms, and orchestrate the dance of particles. They are the strong nuclear force, the weak nuclear force, electromagnetism, and gravity. Come with me and let's explore the forces that make everything, well. Let's begin our exploration with the force that is perhaps most familiar to you, the one you contend with every single moment of your existence: gravity. It's that persistent, ever-present tug that keeps your feet firmly planted on the ground, that brings the rain down from the clouds, and that dictates the graceful arc of a ball thrown into the air. You feel it, you live with it. But do you truly comprehend its cosmic significance, its subtle yet relentless shaping of the universe? It is the universe's great gatherer, the silent sculptor of worlds and galaxies. Think about it. Every object with mass or even energy exerts a gravitational pull on every other object. It's a universal invitation to come closer. This is the force that meticulously assembled the Earth beneath your feet, particle by particle, over billions of years. It's the invisible tether that holds our moon in its faithful orbit, orchestrating the tides. And on a grander scale, it's the maestro conducting the celestial waltz of planets around our sun, and indeed our entire solar system as it journeys through the Milky Way galaxy. But here's a curious twist. For all its dominion over the large-scale structure of the universe, gravity is, by an almost unimaginable margin, the weakest of the four fundamental forces. Consider this. You can effortlessly lift your smartphone from a table. In that simple act, the electrochemical forces within your muscles are overcoming the gravitational pull of an entire planet, all 6 sextillion tons of Earth. So how can such a feeble force hold such sway over the cosmos? The secret lies in two of its unique characteristics: its infinite range and its cumulative nature. Unlike some other forces that operate only over microscopic distances, gravity's influence, however faint, stretches across the entire expanse of space-time, and critically, it's always attractive. It never repels. Every bit of matter adds to the call. And over cosmic scales, these whispers combine into an irresistible chorus. This relentless additive pull means that when you have enough mass concentrated in one place, like a star or a galaxy or a supercluster of galaxies, gravity becomes the undisputed ruler. It's the force that ignited the stars, by crushing vast clouds of gas and dust together until their cores became hot and dense enough for nuclear fusion to begin. Now let us turn our attention to a force that, while perhaps less obviously shaping galaxies, is intimately responsible for the structure of matter itself, for the light that allows us to witness the universe, and for the very processes that animate life: electromagnetism. If gravity is the universe's sculptor on the grandest scales, then electromagnetism is its master chemist, its chief electrician, and its brilliant illuminator. It is the force that governs almost every interaction you experience in your daily life. Think about the world around you. The solidity of the chair you're sitting on, the fact that you don't simply pass through the floor, the vibrant colors you see, the warmth of sunlight on your skin. All of these are manifestations of the electromagnetic force. It's the force that binds electrons to atomic nuclei, creating atoms. It's the force that then links these atoms together to form molecules, the building blocks of everything from a grain of sand to a human brain. At its heart, electromagnetism deals with electric charge, a fundamental property of matter. Particles can be positively charged, like protons, negatively charged, like electrons, or neutral, like neutrons. And the rule is simple yet profound. Opposite charges attract, while like charges repel. This fundamental principle is the engine behind all of chemistry, dictating how atoms bond, react, and arrange themselves into the incredible diversity of substances we see. This force is, quite frankly, astonishingly powerful compared to gravity. The electromagnetic repulsion between two protons, for instance, is about 10 to the 36th power times stronger than their gravitational attraction. If it weren't for the fact that most large objects are electrically neutral, with an equal balance of positive and negative charges canceling each other out, electromagnetism would utterly dominate gravity on all scales. Electromagnetism manifests in two intertwined phenomena: electricity and magnetism. We are all familiar with electricity, the flow of charged particles, typically electrons, that powers our modern world, from the lights in our homes to the intricate circuits within this very device communicating with you now. Chapter 3. The strong nuclear force, the unbreakable grip. We've explored gravity, the cosmic architect, and electromagnetism, the animator of our everyday world. Now we must venture into a realm far smaller, far more energetic, and governed by a force of truly astonishing power, the strong nuclear force. This is the titan of the fundamental forces, the undisputed champion of binding power, operating within the infinitesimally tiny confines of the atomic nucleus. Without it, the very concept of matter as we know it would simply disintegrate. Imagine peering into the heart of an atom, into its nucleus. For any element heavier than hydrogen, this nucleus is a crowded place, packed with positively charged protons and neutral neutrons. Now remember what we learned about electromagnetism: like charges repel. Those protons, squeezed together in such a tiny space, are all positively charged. The electromagnetic force is desperately trying to push them apart with incredible violence. If electromagnetism were the only force at play, atomic nuclei would instantly fly apart. So what holds them together? What overcomes this immense repulsive force? The answer is the strong nuclear force. It's like an incredibly powerful subatomic superglue. It acts between the particles that make up protons and neutrons, particles called quarks, and by extension it binds protons and neutrons together to form stable atomic nuclei. This force is so potent that, at the distances found within a nucleus, it overwhelms the electromagnetic repulsion by a factor of about 100. This incredible strength is its defining characteristic. It is by far the most powerful of the four fundamental forces. Chapter 4. The weak nuclear force, the alchemist of particles. Our cosmic journey now leads us to the most enigmatic and perhaps subtly named of the quartet, the weak nuclear force. Don't let its name fool you. While it is indeed weaker than both the strong nuclear force and electromagnetism, it is still significantly stronger than gravity. More importantly, the weak force possesses a unique and crucial capability that the others lack. It can change the very identity of subatomic particles. It is the universe's alchemist. This force operates like the strong force only over extremely short distances, even shorter in fact, confined to less than the diameter of a proton. Its primary stage is within the heart of atomic nuclei, and in the interactions of fundamental particles. The weak force is responsible for certain types of radioactive decay, most notably beta decay, where a neutron in an atomic nucleus transforms into a proton, an electron, and an antineutrino. Or, a proton can change into a neutron, a positron, and a neutrino. This ability to mediate particle transformation is its superpower. It allows one type of quark to change into another type of quark. For example, a down quark can become an up quark. This flavor change, as physicists call it, is fundamental to the stability and evolution of matter in the universe. Without the weak force, the sun would not shine, and the rich tapestry of elements we observe would not exist. Consider our sun. It's a gigantic fusion reactor, primarily converting hydrogen into helium. The very first step in this process, the proton-proton chain reaction, involves two protons fusing. However, for helium to eventually form, some of these protons must transform into neutrons. Chapter 5. The Cosmic Quartet, a Symphony of Forces. We have journeyed through the realms of the four fundamental forces, each a distinct voice in the cosmic symphony, each playing an indispensable role in the universe's grand design. From the gentle, far-reaching embrace of gravity, to the unbreakable grip of the strong nuclear force, from the vibrant spark of electromagnetism, to the subtle alchemy of the weak nuclear force. These interactions collectively write the rules of reality. Let's now bring them together to appreciate their comparative strengths, their unique domains, and how they collaborate to run the universe. First, let's revisit their hierarchy of strength, which can be a bit counterintuitive. The undisputed champion, the heavyweight of the quartet, is the strong nuclear force. It is phenomenally powerful, but its dominion is strictly local, confined to the infinitesimal scale of the atomic nucleus. Think of it as a microscopic vice, incredibly strong but with jaws that only close on the tiniest of objects. Its role is to bind the fundamental constituents of matter, quarks, into protons and neutrons, and then to hold these particles together to form atomic nuclei, the very heart of atoms. Next in line, significantly weaker than the strong force but still a formidable power, is electromagnetism. This is the force of light, of chemistry, of all everyday pushes and pulls that aren't due to gravity. It governs the interactions between electrically charged particles, binding electrons to nuclei to form atoms, and atoms together to form molecules. Unlike the strong force, electromagnetism boasts an infinite range, though its effects are often neutralized over large scales due to the equal presence of positive and negative charges. It's the artist of the material world. Then comes the weak nuclear force. As its name suggests, it is weaker than both the strong force and electromagnetism. Like the strong force, its influence is also extremely short-ranged, limited to subatomic distances. So the next time you casually drop your keys, feel the warmth of the sun on your skin, or gaze up at the star-dusted canvas of the night sky, take a moment to remember what you've learned. You are not just a passive observer, you are an active participant in a universe governed by these four fundamental forces. That falling object is a dance with gravity, the sunlight a gift from nuclear forces deep within a star, transmitted by electromagnetism, and the stars themselves are held together and lit by this incredible cosmic quartet. You are in every moment experiencing the fundamental forces of nature at work. They are the silent, invisible architects of your reality, shaping everything you know, everything you see, and indeed, everything you are. From the quarks and leptons that form the building blocks of your atoms, to the vast superclusters of galaxies stretching across billions of light years, these interactions weave the intricate and beautiful tapestry of existence.